Hello and a warm welcome from my side to my session, Fast Feedback with Pull Request Deployments. In today's session, we are going to have a look why we should perform deployments on our pull request, and of course, how we do that with Azure and Azure DevOps. My name is Marc Müller. In case you don't know me, I'm from Switzerland. I'm working for Texture, a Swiss consulting company. I'm an MVP for Azure DevOps, so I mainly do consulting projects all around DevOps, Azure, and enterprise application. We also do individual software development with our team, and we also have two products on the market, an OpenID Connect identity server, as well as a framework to develop enterprise applications with .NET. So let's get started. In case you want to have the slides, don't take too many notes. Here is a QR code, a link where you can download all the slides. So everything you see is available for download, so you don't have to take any notes. If you have any questions, use the chat. I'll try to answer them towards the end of my presentation. Later on, I'm also available in the Q&A room in Gathertown. So if you have any additional questions, just try to ping me there. Okay, so pull request deployments. Let's start with a short demo to get into that topic, to see what we want to achieve, that we can have a look later on how we actually do that and implement that. The demo is a very simple application. Maybe you have already seen it. I use the same application for many demos as well. So it's a web application which shows you a joke about developing, and it consists of a front end, a backend API, and as well a relational database. So we have a couple of services, we have some problems deploying a database, and we want to do a pull request deployment with it. To not lose too much time actually watching the build agents rebuilding it, I did the demo before and cut it together, so we have the best way to go through it efficiently. So here we are in our Azure DevOps environment. This is our pull request. We do a couple of changes, like changing the color to red, that we immediately see the deployment of our pull request, change something in the backend that we have to redeploy the API and the API and the database as well. And let's see how it looks like. Then we are digging in on how we are going to achieve that. So in our pull request, we see a couple of changes. So I made some changes to a controller as well as the index page. I just turned the background color to red, that we immediately see our deployment. So the main part of the pull request deployment is this checks window. We want to achieve that we see what has been checked, that it was compiled, deployed, and tested as well. So if we have a look at our environment, I'm using here a Kubernetes cluster, we also see that I've got a dedicated namespace for that pull request. Inside this namespace, my pull request deployment deployed those services. So I have the backend API, the frontend API available in my cluster. If we switch to Azure SQL, we also see I got a dedicated database which has been deployed in order to test. So the pull request provides me or my team a lot of additional information. I added some discussions here, providing the URLs of our pull request, or PO can simply click there, access the application. So first of all, here we see the deployed backend API, and we can also use the front end link to see our front end in action. Keep in mind that we also see on top right this feature flagging. So in this application, we use some feature flags for pull request deployments in order to change the connectivity to different backends. Last but not least, test automation should also be included in the solution. So let's have a look at the pipeline as well. So let's open our deployment pipeline of our pull request, have a look at our artifacts, and here we can find also video of our pull request deployment. So if anything was breaking during the test, we can have a proof, or we can see what actually happened with our application. And here we've got green test, but we can still watch our test automation running our application within the tests. So this was really a really short intro to just give you an idea of what we want to achieve. We want to achieve that we are automatically building, checking, deploying the application, and for sure run test automation in terms of regression tests towards the application. And this is the critical part before we integrate it into our main branch in order to have to be sure that we are not introducing any bug into our application, because we want to have an ongoing deployment mechanism. So we need to check our code before it gets integrated. So with this teaser, let's have a look what we're going to do in this session together. First of all, I'd like to answer a couple of questions, or providing you a motivation why we should do PR deployments in our setup, why it should be the default actually in a system to have PR deployment enabled. Then we're going to have a look at Azure pipelines. So how do we achieve all of that stuff in our pipelines? How do we implement? There are a couple of tricks you need to know in order to get there. Then, of course, we also need to clean up. If we close a PR, if the PR is integrated, etc., we need to clean up all the things, because otherwise, well, we are going to pay for a lot of resources in Azure we don't use anymore. So it is very important to have triggers indicating if a resource can be released, which has been deployed during a pull request deployment. Then a couple of words to database deployments. So a lot of Hello World examples are never touching a database. So we have to deal with databases, with schema changes as well. And this has to be integrated in our setup as well. We are going that far that we also need to set up security and so on and so on. So I'd like to show you a little bit of a real world implementation or real world problems, how to solve them, because usually you have dependencies like a relational database as well. And then, of course, the target environments, how we tackle that. Okay, so why should we do it? The answer is pretty simple. We need to fail fast. Failing fast provides a lot of benefits. The sooner we know that we broke something, the sooner we know that we have to have a look at it, the better it is. I'm still in my context. I can quickly switch over, do the fix, redeploy it, check it again, instead of waiting weeks or months until the QA department is going to test it. If you have a look at the following illustration, years before, or still today, some companies run a traditional Q&A workflow where you're implementing all the features, and then there is this magic code freeze. And then the QA starts testing, is filing bugs. The development team needs to fix them. So the problem of this actually is that you're piling up a lot of features which have been untested. You're working and working and working, and maybe weeks later you get a feedback to your feature which is not working as expected. You need to rethink the whole thing again. You need to get into the context to be able to fix it. This is not a good solution. It's pretty obvious. So there is a better way. It's failing fast. We achieve that, for example, with pull request deployments. So therefore, actually, we have a really flattened curve. I'm creating a new feature. It is going to be tested. It is going to be deployed. It's fully isolated. My change is isolated, deployed, and tested. So I get a feedback maybe 10 minutes later, and I can see what's not working. And therefore, I can fix it immediately without a big context switch. So what we actually do is shifting left. We move the testing process to the left side of the development process. So it's mainly situated in the dev area. And for that, therefore, we're just integrate the testing in our sprint, in our feature development, and of course, into the pull request, because without the software being tested, we're not going to integrate it. This enables us to have a fast detection and fix. And we need also to shift the testers. The testers should be part of the team. To achieve that, they should do test automation implementations, that we have the regression testing available. Okay, why or what are the benefits? Yeah, well, we reduce a lot of costs. So there are statistics that they are around 50% more effective with having these fast feedback cycles. We have early bug detection, means we have in general better quality, and we have an effective resolution of bugs. So test automation is key. If we do that, we need test automation. We need regression testing, because every small change will be deployed as part of the pull request. So we can run and run and run over our test automation again and again. So this is why we need this automation and perform the regression testing, so that we are sure that everything is working correctly. So long story short, we reduce test times by implementing it once, running it 1,000 times. It's a regression test, so we can rerun for every other feature being developed. For sure, we can optimize that. We could have a partial run if the tests are too much, or if they run hours, we could also optimize that as well. And we do not want to have those manual repetitive tasks anymore. So the question now is, where do we do it? And well, the answer is simple. There is no better place than production. So in any case, when we do the testing, when we do the deployment environment, when we do deploy our pull request, we need to be as near as possible towards a production system. So, because if we're testing it slightly different, we do not have the same behavior, there could be other reasons that it is going to fail in production. So since we have Azure, it's that easy to clone an environment, to recreate the environment based on infrastructure as code, and this is where the power comes from. So it's that easy with Azure to have a completely dedicated, isolated environment within minutes or seconds, depending on the complexity, and this is exactly what we are going to do. So we need production-like environments because we need to do a full integration every pull request. We want to have real scenarios with real tests, no simplification, because those things are the ones which are going to break when we deploy to production. So it's actually like the production. There shouldn't be any difference or not a lot of differences. We can deal with real flows, real delays, real latencies, and so on and so on. And basically, if we really like the production environment, we also reduce the no repro bugs because we can actually reproduce them because everything is the same. So as a first conclusion, should we do only shift left? Well, we should do shift left, but there is never you can't do any tests later on. There might be reasons for your application to still have some Q&A work done after it has been integrated, but the goal is that we test as much as possible on the left side of our development process. And yeah, it is really important to reduce the cycle times, having this fast feedback. I need to be in the context, still in the context to fix the bug efficiently, and we should be as near as possible at production environments. So what do we need? We need a CI build which produces all the artifacts. We need to have a proper versioning because we will have many deployments throughout the day, and we need have some like bundles to roll out the code, database structure, maybe also some initialization work. So it's not only the DLL you should actually produce inside the CI build. And because of test automation, for sure, you have isolated tests. A test, you create the data, then you do some actions, you verify it in like a AAA pattern in your tests. But maybe you need some initial data, some data which is needed to also test the database schema deployment as well. So maybe you should also think about producing an amount of test data, a test data initializer from within your CI build. And of course, we need some base infrastructure. We could really create everything from scratch, every pull request deployment, or we have some base infrastructure like having a single cluster we are deploying to, having elastic pool for Azure SQL, and we are just creating a database inside it. We already have a network setup which is reused, and so on. So there's still the possibility to have that things done once and reuse them. The test automation should be in place. So a pull request deployment, well, we can figure out that it is deployed correctly, but you should also run tests. So mainly functional system tests, component integration tests. Those could be API tests, UI tests as well. So the CI build, what does it look like? This is the CI build output of my previous example of this dev fun. As you can see, we're actually producing more than just the DLL within that build. So as you can see, this is the artifact output. So this is the API, this is the DLLs. In this case, it's container, it's Helm configuration, etc. You see as well DAG packs. So this is the database schema, which belongs to the same version as we just created. We also compile our system tests as an artifact. We have some test data, initializations, and so on and so on. So your CI build should really produce all the artifacts which belong to that particular version. We're going to integrate, because then it's really simple to move everything towards a deployment environment and not forget anything or be not compliant or compatible to the version of the database, etc. So this is really important, producing all the artifacts which are needed during the whole deployment cycle. So how do we deploy it? Well, it's the same thing as we usually do. We should use infrastructure as code. So it depends a little bit on your solution, what you're doing. So usually in Azure, you use some kind of bicep or ARM templates. You can also integrate scripts in Azure pipelines with Azure CLI to get there, or use any third-party tool like Terraform, Pulumi, and all the others you might know. It is just important that all the configuration, how to get to your deployment environment, is in code, because if you're creating a feature branch for the pull request and you need to change some infrastructure, it is tested as well. So all the infrastructure definition needs to be in the code repository as well. Then permissions. What do we need to know about permissions? So in general, a PR deployment should run with a very isolated permission set. Preferably, you completely isolate production and test environments. We often go that far that even though we have multiple PR deployments side by side, each PR deployment has its own permissions for database access, resource accesses in Azure. There might be a single service principal to actually do the deployment of those PR environments, but at the end, it should be at least privileged permissions to do that as well. So don't just open everything up if it's just a PR deployment. Then we shouldn't run the deployment within user permission, because it gets very complicated. And usually the Azure admins are not that happy if all your developers could create any resources which are not controlled. Therefore, we use, in this case here, Azure pipelines with a service principal. So it's a single principle being able to deploy those environments. So we are in full control. There are no surprises what has been created. We could also use Azure deployment environment. It's currently in preview. There you could also have deferred deployments, that you provide the permissions to a user to select a deployment there, but the deployment itself is running within Azure deployment environments. We could also use GitOps pull-based deployment models, that we put the artifact somewhere and they get pulled and deployed. It's basically just the agent pattern the other way around as we use with the pipelines. So deployment mode, preferably push and every change. This is what we usually do in PR deployments. The same goes for a pull-based model. We could pull on every change, or there is technically also a possibility to have deployments on demand. But again, we want to have a full coverage of it. So usually we really push or push on every change inside the PR deployment. So let's have a look how we do that. Usually the pipeline design is as follows. We have a base infrastructure CD, really setting up networking, clusters, elastic pools, and so on. And then our pipelines are for each service a pair of pipelines with a CI build, which creates all the artifacts. And this one is then triggering a CD build. Why two pipelines? It is really important. We want to rerun the CD over and over again without recreating the CI. So we have a single artifact in this very version, and then we're able to deploy it over and over again. This is why we have a separation of those pipelines. Inside those pipelines, you have the classical going to production road, and then there is a fork for PR deployments, because we need to do a couple of things differently in a PR. This is why we fork the logic and do some extra steps inside the CD deployment. So then we need to talk about status and comments. The PR system of Azure DevOps is very feature-rich. So we can add additional customized checks, like the deployment was successful, test automation was successful, we checked for secrets, and so on and so on. And we can also add comments inside the pull request to notify the user about the deployment, about something. So the pull request should really be the only interaction for a change, and everything regarding that change is documented inside the pull request, and we can easily add features to that. Okay, so let's have a look at that. What we see here, basically, when the CI builds are running, first of all, we need a CI build running, and then once they're finished in green, there are additional checks being added. So we can dynamically control that by API to say, well, if the CI was successful, we need a successful deployment with test automation as well, and implement that with those pull request checks. We can do additional checks like secret scanning and so on and so on. So large companies, they have, I don't know, sometimes 20, 30 of those checks before a pull request really can be integrated. And for sure, as you have seen, we can add custom comments to it, like pushing a URL to access the application for manual validation, and so on and so on. This can also be automated. So how we are going to do that? So first of all, we need branch policies. Whenever we are dealing with a pull request, we need to set up branch policy. It's like the guard before integration, and everything which is there in the policy cannot or shouldn't be overridden. Well, as an admin, you can override it, but a normal developer is not able to integrate code if the policies are not met. And we can do a lot of different policies like reviewers, pipelines, traceability, and custom policies. And this is very interesting to bring in your own logic. How we're doing that, basically you go to repository settings, and then you select the repository, you select the branch you want to protect, and then first of all you have a lot of standard policies like setting reviewers, checking for linked work items, checking for unclosed comments, define the merge types, and so on. And now there comes the interesting part. First of all, we can add any pipeline as a build validation to it and make it mandatory to succeed. Simply, we need a green pipeline, whatever this pipeline is doing. If it's building, testing, deploying, we don't care. We just need a green status. Within those pipelines, we are able, through the API, to add some additional checks. So we add status checks to it. I'm sorry, wrong slide. We add status checks to it. Those are the custom ones. So we call the API, say, well, add a check to this pull request, and it's basically just a check feedback. But if we add it to the pull request, it is available here, and we can basically define a check as a policy by making it mandatory. So this is how you do it. You have those status policy windows, sorry for that, status policy window, and you're going to add those status checks towards your branch policies. Okay, so let me quickly see. What we need now is we need to set the whole thing up. So the CI pipeline, first of all, needs to have an identified artifact. So we need versioning. We need to build all the artifacts. Of course, we do already run white box tests, etc. And then we publish the artifacts we need for the deployment. So you can see here that we have a PR version. So we add an additional extension to the semantic version, like a pre-release label, to identify the PR. And as you can see, CI from master or main doesn't have that and has a proper semantic versioning. So first of all, we need to be able to distinguish and use this version throughout the whole journey of our pull request deployment. So usually you just add a task, a build versioning task. You can use any tool what you want. It is just important that every commit will change the version. So every time you're having a slight change, which means you have a new commit, we'll change the version of it. So we can track this specific version throughout the whole journey, because you could have, I don't know, 100 updates to a pull request, and we would end up in 100 redeployments of that with a retesting. So it is very important that you use some versioning which is capable of doing that. Often we use the Git version for doing that. So we have a strict commit reference or use the commits to calculate the versions. Inside the actual CI, we are just producing all the different artifacts, like the web application, the tests, database schema, and so on and so on. So now we need actually to create this status, this additional check. So first of all, you're able to have conditions on our tasks in pipelines. So with that condition, I'm adding an additional task just for the case of a pull request deployment. We do that by checking the build reason. So if a CI build is triggered by a pull request, we've got this build reason. So we're able to run this specific task only if this is happening in a pull request. And then secondly, we're adding this status check through an API. Here, I used an extension. You could also directly call a RESTful API, but it's easier with an extension. And what we do here, before actually the CI gets green, we add a policy or a check which is configured as a policy to not allow the pull request to be closed before the deployment hasn't been done correctly. So this prevents it to just click in the right time to still close it. So before the CI is actually closed, we add additional check, which is then pending, and you can't close the PR as well. So then in the CD pipeline, we need to deploy the whole thing. First of all, we need to create some configuration. We need to create the web hosts, the routing, the database, the setup security. So we do the whole thing like a production deployment. Then we actually do deploy the application. We need to deploy the database schema if you have a relational database or any other dependencies we might need to set up. Often we do some test state initialization, that your tests already have something on the screen that you need to page, etc., because testing with a single entry is functionally correct, but you're able to test more if there is a little bit of data. Maybe you also want to have some regression testing on in terms of database schema upgrades, etc. So you might want to restore a backup and then apply the schema onto it, etc. So it is important to have everything in there. So if we have a look at our CD pipelines, as you can see, they use the same pattern as before. So we use this version of the CI and actually bring it to the CD pipeline, that again, we have this identifier through the whole journey. There is a little extension to it. You see this -1. So we have the build version plus the deployment attempt. So if you rerun the same pipeline over again, same artifact, we're increasing the counter behind the semantic version of the artifact. And so we can also immediately see that it has been deployed multiple times. How do we do that? Well, it's pretty simple. We can define the CI pipeline as a resource, add some trigger to it, and say, well, if it has been successfully run, trigger this pipeline, which is the CD pipeline. And then we can also use the version from this, or reuse the version from the CI pipeline. So we can go to the resource reference, $resources pipeline, CI build is the alias, and read out the run name and just add the release version, so the deployment attempt to it. And we can guarantee that the same version again is available throughout the whole journey of it. Then, next thing we need to do is basically, well, calculate some variables, database names, URLs. We often just use the pull request ID because this is a unique ID throughout Azure DevOps to be integrated in the URLs, in the databases, and so on. So everything which is created for a specific pull request will have this pull request ID baked in. And then we just do the rest of the setup. In my case, it's case, namespaces, databases, identities, and so on, and some data initialization. So then we need to run some system tests for sure. Do whatever you want, perform some API tests, run some UI tests, etc. And then we also need to update this pull request status. So we created the status inside the CI build, and now we need to update it at the end of the CD build actually to do that. How could that look like? Just as an idea, it's again a demo example. Basically, I've got here some script running, a script which gets some information of different things which might have been failing, and I'm calculating basically the overall status. So is it succeeded or is it failed? And then I'm using again an extension instead of just calling the REST API of Azure DevOps and providing this state to the policy. So I'm basically setting this traffic light inside the pull request to either red or green after everything has been deployed, the test automation has been run, my script calculated all the different inputs, and then set the final status check if it's successful or not. Then what else can we do? Often we need to add some comments like, hey, I deployed it there, it's available there, whatever. So we are just going often to just run some scripts to actually identify, in this case, a deployment URL in case you want to do some manual validations later on. And last but not least, this is the actual extension to perform this comment. Either you call again the API directly or just use this pull request comment extension, which is available on the marketplace, which does the same and just adds the comment dynamically into your pull request. If you're interested in all those extensions I used, again, either you just call the API. If not, here is a list of all the extensions available in the marketplace to make that happen. Okay, so now one important part is cleaning up. How do we clean up? How do we know that the pull request actually was aborted, integrated, and so on? It was quite hard to do so in the past, but luckily Azure DevOps has some new feature. So what we need is we need some extra triggers, because pull request completion is not that we push something, that we have such kind of events which is usual for a pipeline. So we really need an event when the pull request has been integrated or aborted. So we could use the pull request update. We could also use work item updates and so on, everywhere where we set the logical state to either aborted or succeeded. Luckily, there is a new functionality inside Azure DevOps with the incoming webhook service connection. So what we can do basically is we can define a resource which is listening on a webhook and then triggers a pipeline. Let's have a quick look on how we can do that. So first of all, we can do push something to a URL by using a service hook. So service hooks can produce a webhook call of more or less all the events available in Azure DevOps, including pull request updates. This is exactly what we need. And we need to point it to our incoming webhook trigger for the cleanup. So what we do actually is we define an incoming webhook, choose incoming webhook in the service connection, give it a name, in this case PR updated, and just create it. Then we need to create a service hook, say, well, if there is a status change on the pull request, just, so it's a repository status change, and then we have a target URL. So when we create an incoming webhook trigger, we get this PR updated URL automatically created by Azure DevOps. We use the Azure DevOps incoming webhook URL to be the target URL of this service hook trigger when a PR updates, and we now combined basically the events of a pull request with triggering of a pipeline. So once we set that up, we have the triggering in place, and we just need to use it. This is how we do it. We define a resource in our pipeline. It's of type webhook. We use our webhook alias, the connection. We can also do some filters on it in addition. So here, for example, I'm filtering my repository, which means that every time this PR is updated, it is triggered. And then basically we can run our cleanup logic as a pipeline, like deleting all the Azure resources and so on. And again, we can use additional conditions here. So we can check the status that it is either completed or abandoned. And we're only interested in that kind of events for really destroying our resources in Azure. In the cleanup, it's pretty simple. We again calculate all the names, all the aliases, the database, namespaces, and so on, and just run some code to delete it. Whatever you created, you just do the opposite and delete it. Maybe you just created a resource group, then it's pretty easy. You just delete the resource group and you're good to go. Okay, just a few words since I'm almost running out of time. What about database deployment? Long story short, you need to treat the database as code. So database should be developed like a .NET or code development. It should be integrated into your development cycle. And if you use tools like SQL Server data tools, every SQL object is stored as a SQL file within your Git repository. So it gets branched, etc. We can create a DAG pack out of it and then deploy it. I would really like to talk a little bit more, but I'm really running out of time. So SSDT is currently my favorite tool. It is not perfect. There are some things missing. If you're interested in that, I just quickly point you to this URL, github/fortexture/SSDT data migration. We created a little add-on to support multiple scripts, script management for custom migration scripts, etc. inside SSDT deployment. So if you're struggling with that, reach out to me later on or go to our GitHub repository and have a look. So before we close the session, a few words on the deployment as well. So if we do pull request deployments, there are different strategies to do so. So we could either do a full deployment, which means creating all the resources we need, even though if we just changed one service out of 10 microservices, we would always deploy all of it. It's pretty easy to do that because it's a target environment as defined, but it costs you a little bit more money because you need more resources to do so. On the other hand, we could use a subset deployment, which is faster, which is cheaper, but it could get really, really cumbersome finding the logic how to combine that. As an idea, what that means is the following. Either we do a full deployment. So we have pull request deployment, we have a dedicated database for sure, and we deploy all the services, even if they changed or didn't change. Here we have two changes, or we could also do that in terms of deploy only a new one and still deploy the front end, but from the main branch version. So we still have a full deployment setup, which is pretty easy. We just deploy the changed ones, and for the others, we just use the stable version. This is really easy to achieve, whereas the subset deployment gets a little bit more nasty. So if only the front end change it and we deploy only the front end needs to talk to the back end. Therefore, we need some feature flags being there to say, well, front end go to this backend URL. And if we still are going to deploy the backend, then switch it over and go to this backend instead. So as you can see, this logic is getting quite complex, and therefore, if you reach a decent level, like having 10 or 20 microservices, and instead of implementing all those combinations, maybe a full deployment is the easier way. Maybe you have a message bus and you need to define the routing. It's also easier to have a dedicated namespace, everything deployed. It's a lot easier. It doesn't give you that much headache, etc. What else? One approach also, just quickly to remember or to tease you a little bit, one thing you could do actually is, for example, if you do a Helm deployment within Kubernetes, you package everything as a Helm chart and use init containers and deployment containers. So instead of having a pipeline running the database deployment, the web app deployment, etc., we could just define a single Helm release where we have our app. This one starts init container, which blocks the app from being deployed. This one is then waiting for a deployment job, setting up the database, schema, etc. Only after the database has been finished, the init container is finished, and then the actual deployment of the application runs. So just to provide you as an idea, you could also create some application packages like a Helm package or using other technologies, which are self-contained and have the majority of deployment logic inside your application package, and therefore also your pipeline logic will be a lot less complicated, because in the case of production deployment or pull request deployment, you're just releasing your package with the right configuration values, and there you go. So this was already everything I wanted to show you. Let me quickly see where our mouse is. So as a quick recap of my session, what we learned so far is fail fast, deploy it, fail immediately. You're in the same context, you can fix it fast. And then only if we integrate it, we have the clarity that it runs the same in production. So we have the same production environment or a copy of it. We integrate everything so we can test everything. So we are almost 100% sure it won't fail in production. Then the pull request should be the only point of interaction where all the changes come together, where all the decisions are being made, and only if everything is green inside the pull request, you're going to integrate it. And what we have seen so far is pipelines have a lot of features. They are not always that obvious, but actually you have conditions, you have different triggers, we have templates, and so on and so on. So we can easily build a quite complex system how to deploy your application for peer deployments as well as the real production deployments. With that being said, thank you a lot for being here. Thanks for your attention. I will be available in the Q&A room in the Gather Town. If you have any questions, just ping me there. And have a nice day as well. Please join the other session. As you can see, there are more sessions coming up. Have a nice day. Thanks a lot. Bye-bye.